Now that we've done the parameters and the constants, let's take a look at how we actually implement that function that I showed you. This current func is the implementation of the equation I showed you earlier, and it looks essentially the same. You can type this out like you would essentially on a calculator. The other function we have is the sine func, and this is our way of changing the sign from cavity to cavity. And so what we do then is just have a sine that shifts at the cell length. Its half wavelength is the cell length, such that it oscillates from positive to negative on either side. And so we do this just by doing the sine function divided by the absolute value of that same function. So that's just going to be plus or minus, and we're going to use that here in the space-time function to get our overall current function. This is where everything comes together. So it's the sine function is a function of z here, because the cavity, as we know, is elongated along z. So that's plus minus plus minus. The current function, which we looked at earlier, is the actual function in time. And that's it. It's just those two multiplied together. And we feed those functions x, y, and z along with frequency low, frequency high, and those are all the inputs that you can see defined here. Frequency low, frequency high, T off, del F. Right. We've done materials, we've done geometries. Let's take a look at the grid real quick. If you recall, VSim will set up the grid automatically for you, but as I said, we actually provided these constants, and so I have a constant up here that specifies xmin, xmax, ymin, ymax, and those are the extents of the grid. So when I come down to the grid, I can choose xmin, so I assign it a constant. I go down and say xmin, and that's done by right-clicking. Xmax, I do the same, ymin, ymax, zmin, zmax. And then I also provide the number of cells. And again, we have that automatically calculated with the resolution. So I just assign this a parameter this time, which is x, y, and z cells. And that creates our grid. The next thing we need are the field dynamics. By default, we'll have an electric, magnetic, and current density field. The thing that we need to worry about is the current distributions, because that's what we're going to be driving. So on here, if you right-click current distributions, you can add a current distribution, a dipole current, or a distributed current. We chose distributed current, which you can see the options for here, and we're driving 2, and I'll show you if we get rid of this grid. You can see, if I turn this on, our currents are in the top of the cavity and the bottom of the cavity. And the reason we do this in 2 places is because it allows us a little bit more flexibility if we wanted to examine a different mode besides the pi mode. With the pi mode, you could just have a current running straight down the middle that's oscillating in sign, positive, negative, positive, negative, positive, negative. However, if you wanted to drive something like a crab cavity mode, you might have positive on the top of the cavity, negative on the bottom. Positive, negative, positive, negative. And so having 2 current distributions would be useful. Here, we're going to make these essentially identical. So we can go to the upper one and take a look. We don't care about driving an X current, a Y current, but we do care about driving this Z current along the device. And all we do is pick a space-time func and that current func that we wrote earlier. And then you have to give it beginning, end, beginning, end, beginning, end. And we chose those such that it lines up with the top. And same thing with the bottom. Same function. It's just a slightly different position.